Hi all! In this video we're going to look at visual representation of where the area of a trapezoid is coming from. Now most of you have probably seen the formula before, but here we're going to look at visual manipulations. Areas are usually represented in terms of centimeters squared, meters squared, inches squared, feet squared, whatever unit of measure it's been decided on, squared. Now, a bunch of little squares would not neatly fit into this trapezoid, but if you have a shape that resembles a square or a rectangle, it can easily be divided into little squares of whatever unit of measure it is, or halves of those squares, fractions of those squares. So the area of trapezoid comes about from cutting and pasting the actual figure. Let me animate this figure. So here's our trapezoid and it changes its shape. The basic thing about trapezoid is it has two opposite sides that are parallel. First thing of the formula you notice is there's a half in there. So the half comes from taking this trapezoid and dividing it in half. So let me do this. It is being cut in half with respect to the height, which also cuts non-parallel sides in half. Now the two bases are parallel, and by transitive property, the third line, the cut line, LM, is also parallel to the other two, and you will see why it matters shortly. Now the thing about these angles are they are congruent, and these two are congruent, and they are marked so that you can see what happens with them. Once the trapezoid is cut in half equally, it's being flipped on its side and it becomes a parallelogram. And the cool thing about parallelogram is that its height times its base gives you the area. The base becomes, let me go back to the trapezoid. This DH, the top base, is being flipped around its midpoint and it's added towards the other parallel base, EF. Let's calculate the total width. Let's take base EF and let's add to it base DH, and we get this nice measure. And let's go back to the parallelogram. So in a parallelogram, opposite sides are congruent, supposedly. So let's measure this new distance. Let me stop this. The distance from L to L prime, let me move this. This is just former height. This is height divided by 2, showing you that two new short pieces of heights are congruent. Keep in mind that these measures are rounded off. Okay, so we have L to L prime is 22 centimeters, and the sum of the bases is also 22 centimeters. So adding length of the two parallel sides of the trapezoid gives you one side of a parallelogram of that thing. Now, how do you calculate area of a parallelogram? You take base and you multiply it by height because it gives you the measure of this rectangle, and it still works if you're animating this figure. It works for any trapezoid, all those things, because you can always reset it and we get our parallelogram back. The angle measures are preserved. You can actually see that those are congruent triangles. If I move this little piece of a triangle up, let's make our little rectangle this way. So let's see if the calculations work out. So we have sum of the bases. We have our new height or halves of the height. So let's calculate the sum of the bases times the height, and let's divide it by 2. Here we go, the areas match. That's all.